Dear students, so let us we study today about the topic symmetry elements and laws of crystallography. In the earlier class, you have studied about the two types of the solids. One is a crystalline solid and another one amorphous solids. Crystalline solids have a definite geometry and sharp melting point. And today, the another property of the crystalline solid, that is, the crystals have a definite symmetry. And this we are going to study, and also the laws of crystallography. Now, as I have told you, the crystals have inherent symmetry. The definite ordered arrangement of the faces and edges of a crystal is known as crystal symmetry. It is a powerful tool for the study of the internal structure of crystals. Crystals possesses different symmetries or symmetry elements. Now, let us we restrict our study to the crystals which have cubic geometry. In a cube, we have 6 faces, we have 8 corners and 12 edges. This you have to remember. I repeat, a cubic crystal is having 6 faces, the 8 corners and 12 edges. Now, in a symmetry, map may be defined in rotation to the plane of symmetry, axis of symmetry and center of symmetry, and these are known as symmetry elements. And we are, as I have told you, it is confined only to the cubic system. Plane of symmetry, the point to be noted here is it's divided a crystal into 2 equal halves, and these are the mirror planes. In axis of symmetry, the parallel to the edges of intersection of 2 crystal faces, binary, trigonal, tetragonal and hexagonal. In case of hexagonal, we find in hexagonal geometry, but other 3 we find in cubic system. In case the center of symmetry, it is an imaginary line passing the center. Symmetry is the important property of a crystal. The geometrical entity such as a plane or line with respect to which a symmetrical operation is carried out is called the symmetry element. Several types of symmetry elements are used to describe the symmetry present in molecules and crystals. Out of these, let us study only elements of symmetry. Elements of symmetry includes plane of symmetry, line or axis of symmetry, and the center of symmetry. Coming to the first one, the plane of symmetry. It is an imaginary plane passing through the center of a crystal by which the crystal is divided into 2 halves such that one is the mirror image of the other. In a cubic crystal, there are 2 types of planes of symmetry. Number 1, rectangular planes of symmetry, and number 2, diagonal planes of symmetry. Coming to the first one, the rectangular plane of symmetry. These are the planes situated midway and parallel to the opposite faces. There being a 6 faces in a cubic system or 3 pairs of opposite faces, hence 3 rectangular planes of symmetry are possible. The diagonal planes of symmetry. These are the planes touching the opposite edges, and as I have told you, there being 12 edges or 6 pairs of opposite edges in a cubic crystal, 6 diagonal planes of symmetry are possible. In total, there are 9 planes of symmetry. This I have shown the diagram here. In this diagram, it's a cube. The cube is having the 6 faces, the 8 corners and 12 edges. And in case of the rectangular planes of symmetry, the horizontal plane and vertical planes are given. In case of the diagonal, the planes are opposite edges. They are touching each other. This slide shows there are 3 rectangular planes of symmetry in the first 3 cubes and the 6 diagonal planes of symmetry, the rest of the other 6 cubes. In total, there are 9 planes of symmetry. The another diagram, the slide, also emphasizes the same thing, the 9 planes of symmetry. Now, let us take the another one, that is the axis of symmetry. Now, in this axis of symmetry, now how to define this axis of symmetry? It is an imaginary line passing through the center of a crystal about which the crystal may be rotated such that it presents the same appearance more than once during the complete rotation. In a cubic crystal, there are 3 types of axis of symmetry. Number 1, axis of 4-fold symmetry. Second, axis of 3-fold symmetry. And third, axis of 2-fold symmetry. Coming to the first one, axis of 4-fold symmetry. It is an imaginary line passing through the centers of 2 opposite faces of a cube. On rotating the cube about this line as axis, it will be found that the cube presents exactly the same appearance 4 times in one complete rotation. So, there are 6 faces in a cube or 3 pairs of opposite faces in a cubic crystal. Hence, we have 3 4-fold axes of symmetry are possible, and these are at right angles to each other. Second one, axis of 3-fold symmetry. It is an imaginary line passing through the opposite corners of a cube along the body diagonal. On rotating the cube about these lines as axis, it will be found that the cube presents the same appearance 3 times in one complete rotation. How many corners are there in a cube? There are 8 corners or 4 pairs of diagonally opposite corners. Hence, there are 4 3-fold axes of symmetry are possible. Coming to the third one, axis of 2-fold symmetry. It is an imaginary line passing through the centers of two diagonally opposite edges of a cube. On rotating the cube about this line as axis, it will be found that the cube presents the same appearance two times in one complete rotation. How many edges are there in a cube? There are 12 edges in a cube, or 6 diagonally opposite pairs of edges. Hence, we have 6 two-fold axes of symmetry are possible. In total, there are 13 axes of symmetry in a cubic system. This I am showing in the slide here. So, how these imaginary lines they passes in a cube. Now here I have shown the axis of symmetry, the fourfold axis of symmetry. There are 3 fourfold axes of symmetry. There are 4 threefold axes of symmetry, and there are 6 twofold axes of symmetry. This diagram also shows how exactly the center of symmetry and the axis of symmetry are there. In case of hexagonal structures of the crystals, we found the 6-fold axis of symmetry. Now, next we take the third one, the center of symmetry. Most crystals have a center of symmetry, even though they may not possess either planes of symmetry or axis of symmetry. Triclinic crystals usually only have a center of symmetry. If you can pass an imaginary line from the surface of a crystal face through the center of the crystal and it intersects a similar point on a face equidistant from the center, then the crystal has a center of symmetry. In any crystal, it contains only one center of symmetry. More than one center of symmetry are not possible. In this slide, I have shown there are 9 planes of symmetry, and how it looks, the 4-fold symmetry, 3-fold symmetry, 2-fold symmetry, as well as the 6-fold symmetry, and also the center of symmetry. Finally, so in a cubic crystal, we have 3 rectangular planes of symmetry, 6 diagonal planes of symmetry, 3 4-fold axes of symmetry, 4 3-fold axes of symmetry, 6 2-fold axes of symmetry, and 1 center of symmetry. Totally, there are 23 symmetry elements. So, this is about the symmetry elements in crystals. Based on these symmetry elements, so the laws of crystallography are framed. Crystallography is the branch of science which deals with the geometry, properties, and structure of crystals. It is concerned with the external spatial arrangement of crystal planes and the geometric shape of crystals. It is based on 3 fundamental laws. Number 1, Steno's law of constancy of interfacial angles. Second, Hoy's law of rationality of indices or intercepts. Third, the law of symmetry. Coming to the first one, Steno's law of constancy of interfacial angles. It states that the crystals of same substance can have different shapes depending upon the number and size of the faces, but the angles between the corresponding faces remain constant. For example, interfacial angles in all sodium chloride crystals are found to be 90° irrespective of their size and shape of the faces. Coming to the second law, the Hoy's law of rationality of indices or intercepts. It states that it is possible to choose along the three coordinates axes at unit distances, assume A, B and C, not necessarily of the same length, such that the ratio of the intercepts of any plane in the crystal is given by LA is to MB is to NC, where L, M and N are simple integers like 1, 2, 3 or fractions of whole numbers. Students, the detail about this Hoy's law you are going to study in the subsequent classes. Coming to the third one, that is the law of symmetry. It states that all crystals of the same substance possesses the same elements of symmetry. So we have studied the elements of symmetry in detail. Now the same thing I want to show with this slide. So here the law of crystal symmetry is shown. So whether it is a size is bigger or smaller, all these different types of the crystals, they have the same angles. Now here I have shown the Steno's laws of the crystallography. So whether you take a smaller one or the bigger one, the crystal, they have the same angle. Here also I have shown about the law of rational indices, law of constancy of interfacial angles and the Bravis law, which are the three important laws, so which I have described in this slide. Students, go through this symmetry elements and the law of crystallography and remember these aspects. Thank you.